Hello everyone. In this video, we are going to discuss about double linked list in data structures. This is the outline of this video. This video consists of introduction to double linked list, abstract data type, C program, and advantages and disadvantages of double linked list. Okay, before starting this video, please like the video, subscribe to our channel. It will help me to do much more useful content. Now let us see what is meant by double linked list. A double linked list is a more complex data structure than a single linked list, but it offers several advantages. The main advantage of double linked list is that it allows for efficient traversal of the list in both directions. Basically, the double linked list consists of a node. In that node, it consists of three different blocks. The first block represents the previous link, the second block represents the value, and the third block represents the next link. This is because each node in the list contains a pointer to the previous node and a pointer to the next node. This allows for a quick and easy insertion and deletion for the nodes from the list, as well as efficient traversal of the list in both directions. This linked list can travel in both directions. That is, we can traverse in forward direction or we can traverse in reverse direction. And the insertion and deletion is easy when compared to single linked list. Now let us see the abstract data types. In double linked list, we can perform operations, some of the operations like creation, display, insertion, deletion, search, and reverse display. Now let us look into each operation in detail. First operation is creation operation. We can create a node using a malloc function. You will understand clearly while I am coding. Now, in double linked list, we use two variables, start variable and last variable. The start variable is used to represent the first node, whereas last variable is used to represent the last node. As I said earlier, in the double linked list, we consist of three blocks of a node. The first block represents the previous link, the second block represents the value, and the third block represents the next link. Always remember that in a double linked list, the first block of the first node is null, and the last node is null. Now observe the links. In the first node, the third block consists of an 1000, which represents to the next integer, next address location. Similarly, in the second node, the previous link is 500, which represents the previous node. And the third node is 2000, which represents to the next node. Similarly, for the last node. So this is about creation operation. Now let us look displaying of a double linked list. We start with the start pointer variable. We will display the values until we reach the last variable, last pointer variable. So this is about display operation. Now let us look about insert operation. Suppose if you want to insert a new node with value 25, we will create the node. First we will create the node using malloc function. We will declare the previous link as well as next link to null. And while inserting, first we will fill these null values. Observe that 25 is inserted. The previous link is changed to 1000, which represents to the previous node, whereas the next link is changed to 2000, which represents the next node. Now the node containing address 1000, the next node is next link is changed to 1500, whereas the node address is 2000, the previous link is changed to 1500. Observe the changes. This is about insertion operation. Now let us look into the deletion operation. Suppose if we want to delete a node 20, simply we will use free function and we will change the previous variables. I mean next link and previous link of the corresponding nodes. Observe that here 1000 is getting deleted. So the next node, next link should be 1500. Whereas for the node containing address 1500, the previous link will be 500. So while deleting, we perform three operations. First one, we will delete using free, and we will change two pointer variables. This is about delete operation. Now searching. Initially, we will enter if we want to search a key element 30, we start from the starting variable. We will traverse until we reach the last variable. If we found the search element in the middle, we will return the position and break out of this function. This is about search. Now let us look into the reverse display. In reverse display, we start with last variable. We will traverse by displaying the elements until we reach the first variable. So in linked list, displaying searching is easy, whereas inserting and deleting an elements in the is tough when compared to arrays. So these are the abstract data types. Now let us write a simple C program. Let us write a C program for double linked list.
No, I don't take shit. I got no love for the fakeness. If you wanna play tough and wanna hate this, I'll always show up. I don't ever slow up, no I don't take shit. I got no love for the fakeness. If you wanna play tough and wanna hate this, I'll always show up and make a statement. I don't ever slow up, no I don't take shit. I got no love for the fakeness. If you wanna play tough and wanna hate this, I'll always show up and make a statement. Everything I do so instinctive and so passionate. Every word I move so descriptive like an adjective. I got a vendetta against people who patented being negative when you should be getting after it. I got facts over tracks, this and that. Spitting slow, spitting fast. I could roast, I could gas. Think I'm okay at last, but I don't know if that can erase all the past. And the pettiness, a reflection of the emptiness. Hilarious, you think you're worth my time, you're delirious. Mysterious, because you hide behind a fake exterior. Inferior, you know I'll always be a bit superior. Get off of me, this ain't no humble brag. I want you to hear words, you can say them back. I want you to feel free from the chains at last, and to believe in what you got, it was built to last, yeah. Now that I've been put through hell, I never got anyone's help. I had to do it all myself. I don't ever slow up, no I don't take shit. I got no love for the fakeness. If you wanna play tough and wanna hate this, I'll always show up and make a statement. I don't ever slow up, no I don't take shit. I got no love for the fakeness. If you wanna play tough and wanna hate this, I'll always show up and make a statement. Gonna learn the consequence of being incompetent. Mental health is confidence, dreams and some honestness. I'm not here to save the day, that's for you to take away. I could play a million mind games, but instead I say something not illogical, something that is topical. Rub it on and watch it go, make yourself unstoppable. Dreams are irresponsible, but they're always possible. If you just believe, you could be so remarkable. Thoughts in my head, a collage and they spread. I'll be great one day, going off of my meds. No, I'm not giving up, no, I'm not giving in. I will make it to the top, taking off in the wind. I gotta make it, I'm saving every day to taste it. I'm patient, but my mind, it can hardly take it. I'm chasing a dream that I've had for several ages. A vacant, modern kingdom for the taking. Now that I've been put through hell, I never got anyone's help. I had to do it all myself. I don't ever slow up, no I don't take shit. I got no love for the fakeness. If you wanna play tough and wanna hate this, I'll always show up and make a statement. I don't ever slow up, no I don't take shit. I got no love for the fakeness. If you wanna play tough and wanna hate this, I'll always show up and make a...
Now this is the main function. Initially, we declare the structure of a single node. The single node name is DBL. That DBL consists of three blocks. First block represents the previous link, which is denoted by P link. Second node consists a value. We can either declare a character or a string, but I declared an integer variable. The third block consists of an next link, which is denoted by n link. In the main, and also I declare the pointer variables start to null, start is equal to null, last and temp. In the main function, I declared all the abstract data types which are the operations that can be performed on a double linked list. I'm taking an input integer ranging between 1 to 7. If I click 1, I perform create operation. Similarly, I click 2, insert, and 3, 4, 5, 6, observe the operations. If I click 7, then I will exit out of this code. So this is about the main function. Now I will write each abstract data types functions in detail.
I don't ever slow up, no I don't take shit. I got no love for the fakeness. If you wanna play tough and wanna hate this, I'll always show up. I don't ever slow up, no I don't take shit. I got no love for the fakeness. If you wanna play tough and wanna hate this, I'll always show up and make a statement. I don't ever slow up, no I don't take shit. I got no love for the fakeness. If you wanna play tough and wanna hate this, I'll always show up and make a statement. Everything I do so instinctive and so passionate. Every word I move so descriptive like an adjective. I got a vendetta against people who patented being negative when you should be getting after it. I got facts over tracks, this and that. Spitting slow, spitting fast. I could roast, I could gas. Think I'm okay at last, but I don't know if that can erase all the past. And the pettiness, a reflection of the emptiness. Hilarious, you think you're worth my time, you're delirious. Mysterious, because you hide behind a fake exterior. Inferior, you know I'll always be a bit superior. Get off of me, this ain't no humble brag. I want you to hear words, you can say them back. I want you to feel free from the chains at last, and to believe in what you got, it was built to last, yeah. Now that I've been put through hell, I never got anyone's help. I had to do it all myself. I don't ever slow up, no I don't take shit. I got no love for the fakeness. If you wanna play tough and wanna hate this, I'll always show up and make a statement. I don't ever slow up, no I don't take shit. I got no love for the fakeness. If you wanna play tough and wanna hate this, I'll always show up and make a statement. Gonna learn the consequence of being incompetent. Mental health is confidence, dreams and some honestness. I'm not here to save the day, that's for you to take away. I could play a million mind games, but instead I say something not illogical, something that is topical. Rub it on and watch it go, make yourself unstoppable. Dreams are irresponsible, but they're always possible. If you just believe, you could be so remarkable. Thoughts in my head, a collage and they spread. I'll be great one day, going off.
Okay, this is the create function. In this function, we will create a double linked list. Initially, we declare the start is equal to null. We are scanning the total number of elements which are we are willing to create a double linked list. Suppose I enter 5, a double linked list will be created for 5 elements. If I enter 7, a double linked list will be created for 7 elements. If I enter a negative number or 0, then it will prompt a message like enter a valid range and again ask to enter a valid number. So as I said earlier, the steps to creating a double linked list, we create a node using malloc function. This is the structure of malloc. DBL star malloc, size of DBL. Here size of DBL is 3 because we initially declared with 3 functions: nlink, data, and plink. So the temp of plink is null. We are scanning the second block data, and the third block is set to null. If start is equal to null, then we are initializing start is equal to temp and last is equal to temp. That is for the first iteration, we will assign the start and last to temp. For the remaining iterations, temp of plink is equal to last, last of nlink is equal to temp, last is equal to temp. So this is the process of creating a, this is the code for creating a double linked list. This is the main core logic. Now let us perform display function.
Yeah. Sometimes I get so mad, there's no controlling me. My thoughts get so bad, I'm like, I might grab a bat, I don't know. My wrath, my blood boils over like, oh God, here goes. I lost all feeling from my head to my toes. You said some shit that I can't let go, so just stay tuned for the rest of the show. So have you ever felt betrayed? Switches how you see things, realize something needs change. Cause I know you got me fucked up, let me show you what's up. Cause enough is enough. I'll take a face full of pavement just to make a statement. I know that.
So this is the logic for display function. If start is equal to null, then we will print that list is empty. So as I said earlier, in display function, we start with the starting variable and keep on printing the elements until we reach the last element. So here I am initializing temp variable, temp is equal to start, while temp is not equal to null. We will keep on printing the elements. Temp is equal to temp of nlink. Here nlink stores the address of the next node. So this is the core logic for the displaying function. Now let us perform insertion function. is the logic for insertion function. In the insertion function, we will perform mainly four operations. First one is filling those two empty blocks of a created node, and then modifying next link and previous link of the corresponding nodes. So if start is equal to null, we will print that empty list. If start is not equal to null, then we are asking the position to insert. If we are entering an invalid number, that is a negative number or a number greater than the total number of elements, we are printing that enter a valid number and again asking to print a valid number. So after entering a valid number, we will create a node. A node consists of three blocks. We create a node using malloc function. DBL star malloc size of DBL. Here size of DBL is 3, which corresponds to three blocks. First block represents the previous link. Second block represents the data, whereas the third block represents the next link. This is the syntax of creating a node. After creating, we will assign the previous p link, that is first block to null. We are scanning the second block, that is temp of data. Again, we are assigning the next link, that is third block to null. If POS is equal to 1, that is if you want to insert the element at the first position number 1, that is first element, then temp of n link is equal to start of p link is equal to temp, start is equal to temp. Here temp is the created node. The created node next link is corresponding to start. The start node previous link correspond to the temp. And we are changing the start variable. Start comes to the temp. Similarly, if you want to insert at position n plus 1, that is the last element. The same empty node is created, which is temp. Temp of p link is equal to last. The created node p link is equal to last. Last of n link is equal to temp, and last is equal to temp. We are changing the last variable. If we want to insert a element at the middle, then dbl star, we are creating a pointer variable ins is equal to start. We are iterating that ins to the position -1, and we are performing these four operations. We are filling first, initially we are filling this two empty blocks, temp of p link and temp of n link, and we are changing the corresponding nodes. Finally, we increment the total number of elements. So this is the process for inserting a node in the double linked list. Now let us perform deletion operation. Okay. So this is the logic that we are using for deleting a particular node. Initially, we are scanning the key element. If key is the start of data, that is, if we want to delete the starting element, then we are assigning temp is equal to start. We are moving start variable to the next variable. Start is equal to start of n link, and we are assigning start of p link to the null. We are deleting by using this function free of temp, and we are incrementing the flag value and decrementing the total number of elements. Here n stands for total number of elements. Similarly, if we want to delete the last element, that is last of data, we are assigning temp to the last element. Last is equal to last of p link, that is we are moving the last element to its previous one. Last of n link is equal to null, we are assigning the last of n link to null. Free of temp is used to delete, increment the flag value, and decrement the total number of elements. If element is not equal to start element or the last element, then we are using a pointer variable del, while del of nlink is not equal to last. That is, we are traversing this del link to this next node. If del of nlink of data, that is its next node data is equal to the key element, then we are performing three operations. Temp is equal to del of nlink. Del of nlink is equal to temp of nlink. Temp of nlink of plink is equal to del. These three are the operations we are performing for deleting an particular node. We are performing a free function to delete the node, increment the flag value, and decrement the total number of elements. So if the element is not found, then the default flag value will be 0. If flag value will be 0, then we will print that element is not found. Else element found and deleted. So this is the core logic that is used for deleting a particular node in a double linked list. Now only two operations are left, which is search and reverse display. We will perform those. So this is the logic that is used for searching an element in a double linked list. We initialize the position to 0, key and flag is equal to 0. Here temp we are assigning to the starting node. we are scanning the key element while temp is not equal to null. First, we are incrementing the position. For the first iteration, position will be 1. Second iteration, position will be 2. And so on up to n iterations, where n stands for total number of elements. If key element is equal to temp of data, if that is if the elements match, we are printing that %d found at position. We are incrementing the flag value and passing the temp is equal to temp of n link. We are traversing to the next node. So if element is not found, then the default flag value will be 0, and we are printing that %d not found. So this is the logic that is used for searching. This is the core logic. Now only one operation is pending, which is a reverse display. This is the logic that is used for reverse displaying. Initially, we are initializing temp to the last node. We are printing that element %d temp of data. We are traversing to its previous node using temp is equal to temp of p-link. If temp is equal to null, then we will exit out of the loop. So this is about double linked list. In this we perform total 6 operations: creating, insertion, deletion, displaying, search, and reverse display. Total 6 operations on the double linked list. Now let us execute this code once. There are some of the errors. 88, 122, 140. Now let us execute this code. Again errors. 141. So it displayed 6 operations: 1 to create, 2 to display, 3 to delete, and so on. Enter your choice. I'll create first. Enter total number of elements. Let us enter 5. Enter 5 elements: 10, 20, 40, 50, 60. These are the 5 elements. I think they are not created successfully. So there are some modifications which I did. While in create function, didn't use ampersand symbol. So later I modified it. So now let us run this code. Enter your choice. Initially, I'll create a double linked list with 5 elements. Enter the 5 elements 10, 20, 40, 50, 60. Double linked list created successfully. Now I'll display that. Updated list is 10, 20, 30, 40, 50, 60. Now I'll insert 30 at position 3. 30 inserted at 3 successfully. I'll display it once. See, the updated list is 10, 20, 30, 40, 50, 60. Now I will delete 50. 50 deleted successfully. Now again I'll delete 70. 70 not found. So now fifth abstract data type, I'll use search. Enter key element to search. I will search 60. 60 found at position 5. I will search element 10. 10 found at position 1. So these 5 functions are working successfully. Now let us perform reverse display. So reverse displaying the list is 60, 40, 30, 20, 10, which is working correctly. So finally I'll exit from the code. So these are the abstract data types and various operations that can be performed on a double linked list. Now let us look into the advantage and disadvantage of the double linked list. Some of the advantages are bidirectional traversal. So we can traverse from both forward as well as backward. Especially we'll use this for displaying and reverse displaying of the double linked list. So the second advantage is efficient deletion. Given a pointer to the node, you can delete it in omega of 1 time. No need to traverse from the head. Since you can update both previous and next, which is start and last. Insertion at both ends. So insertion is also flexible. We can insert at the head or a tail. So these are the advantages. Now let us look into the disadvantage of a double linked list. Extra memory per node. So in the double linked list, we use 3 blocks for creating a node. Whereas in single linked list, we use only 2 blocks. First block represents the data, second block represents the next node. So the extra memory is needed to store per node. The second disadvantage is memory complex implementation. So the logic is much more tougher when compared to the single linked list. So the both start and last node must be handled carefully during insertion and deletion. The third disadvantage is slower operation due to overhead. Extra pointer manipulation during insertion and deletion costs slightly more overhead compared to the single linked list. So these are the advantages and disadvantages of double linked list. Thank you for watching this video till the end. Please like, share and subscribe to our channel. It will support me to do much more useful content. Thank you for watching.